Hey everyone, this is the second part of this, what was originally going to be one video on orientation warping, and we're going to finish our orientation warping here. Okay everyone, I have the project open. We're going to navigate to our animation blueprint. And now, inside of our locomotion state, we are going to create some orientation warping nodes. I'm going to give myself some more room. This is more than enough. I'm just going to search orientation warping. And I will take this node and plug it in to forward. I'm going to duplicate and make 6 more of these. I'm going to plug 2 into right. Two into backward. And 2 into left. And now for right in... Actually, everyone, I'm sorry. We're going to delete all of these except for the one in forward, and we need to set the settings before we duplicate it, or we'll have a lot of extra work to do. The body orientation alpha should be 1. The IK foot root bone should be IK foot root. We're going to add 5 array elements to the spine bones array. 0 is spine 1, 1 is spine 2, 2 is spine 3, 3 is neck, and 4 is head. Now, we can make 6 more of these and plug them all in. And the reason that there are extra nodes is because we only have forward and backward animations. And we're using orientation warping to create our right and left animations. And I made a mistake. We only need 5 of these. Forward and backward need 1, the other 2 need 2. So that's 6 in total. Once they are all plugged in, for the locomotion angle setting on the second orientation warping node after the right state machine, I'm going to type in 90. I'm going to do the same for left. And now if I compile this and click play, we can walk left and right now. But anything between our 4 directions doesn't function. And that is where our other 4 orientation warping nodes come into play. Now we need 4 new float variables. They're going to be called orientation direction forward, orientation direction right, orientation direction backward, and orientation direction left. And they are all going to be floats, although I might have already said that a moment ago. So I'm just going to duplicate forward and then rename it and change the end. And just continue to do the same thing. It's easier than typing out everything 4 times. Now, orientation direction forward is going to plug into the top orientation warping node. Orientation direction right is going to plug into the one underneath it for right, and so on and so forth with backward and left. And I'm going to do a little bit more organization here. that looks much better. Okay. So the reason we have these 4 different variables instead of 1, orientation direction, is because we want to calculate the orientation directions differently, because the orientation warping angles are going to have different offsets, because some animations are walking like right, left, or backward. You have to offset the orientation warping because of that, but also because we want to calculate the values separately and simultaneously with a new value every tick. Otherwise, when we begin to blend, the orientation direction forward, or let's just say our orientation direction node, has to change and calculate for orientation direction right instead of orientation direction forward, and that'll show up in the blend. But if we're calculating right simultaneously with forward, we can blend from forward to right, and our value isn't doing blending. We're just blending to another orientation warping node with a different value in it. And that's important, otherwise the character will reset itself to facing forward or do some other weird things during the transition. Now, let's go to our event graph, and let's actually set a value for orientation or orientation direction nodes. And this isn't going to work. It's going to do something, but it's not going to be what we're looking for. But I want to do it this way first to begin with, so that I can just demonstrate why we're going to be doing the bulk of what we're going to be doing in this video. So we need another 4 variables, and these are going to be our orientation offset variables. But before I do that, we're adding so many new variables that I want to reorder some of these. To try to organize things a little bit more. Okay. I'm just going to duplicate orientation direction left. Replace the LT with forward, and direction with offset. And now I'm going to duplicate that and make orientation offset right. Got a case of the hiccups here. Orientation offset backward, and orientation offset left. And I'm going to alt drag each of these out in front of the set cardinal direction nodes for the corresponding directions. I'm going to plug the set cardinal direction nodes straight into the orientation offset nodes, and I'm going to set forward to 0, right is -90, backwards is 180, and left is 90. And I'll demonstrate once we're further along what happens if we do not use an orientation offset, but before I can show you why we're using it, I have to go a little bit further with this. Now, we're going to take our orientation offset and we're going to add it to our direction. I'm going to demonstrate what goes wrong if we just input the direction. Because it's easier sometimes to demonstrate things than to just say or try to teach them through words. Now I'm going to alt drag out our orientation direction nodes, our variables, and we will go ahead and set them with the result of our addition here. I'm just going to plug them straight into, I'm going to plug the execute pin straight from orientation offset to orientation direction for each of these. I'm not too worried about being super organized here because we're going to be changing a lot of that. And now if I play, you can see that this works to an extent, But now first off, there's problems when we are going backward. The character's upper torso spins around when we're going from negative 180 degrees to 180 degrees. And you can see that our character does some weird things occasionally when switching from forward to backward. If I really do some slow motion here, it can become more apparent. But our character foot root bone will do some spinning around. It's somewhat obscured by the starting and stopping currently, but it is still a problem. And all of our problems that we have, or would run into if we continue to play and try to find some more fringe cases with this, will have to do with the hemisphere issue, where with Unreal Engine, it takes direction on a scale of negative 180 to 180, where negative 180 and 180 are the exact same. But mathematically, they are not, and the computer doesn't understand that they're the same thing. And so we could just test if a value is negative and add 360 to it, and then we're on a scale of 0 to 360, and we have the same problem again, this time when going forward. 0 and 360 are the same, but they're not mathematically the same. So let's say you're at 2, and you need to go to 360, or let's say 359. Well, you're going to go almost 360 degrees around instead of just the 3 degrees you need to go, because the computer doesn't understand. And so that is where some of the math and pure functions that we're going to be creating come into play. And now this is just the best solution I found, and I'm going to walk you guys through how to make this. So we need 2 pure functions. One is going to be titled wrap angle, and the other is going to be titled GetAngleDelta. Each of these is going to be pure, which just means that there's no execute pin when you actually drag the function out, and so that you can treat it like you're doing the rest of your calculations with floats and addition, subtraction, division, that kind of stuff. It doesn't need an execute pin to go into it. And so if your function can be pure, it's probably better to make it pure. It's just more efficient. So we're going to begin with our wrap angle node. Function. I keep saying node when I don't mean node. And we need one input titled angle. It is a float. And we need one output. And it is going to be titled return angle. Let's do return angle. Okay. And now the first thing we want to do to this angle input is we want to add a value of 180 to it. Next, we're going to divide using the division, whole, and remainder node. The divisor is going to be 360. And if the remainder is less than 0, we're going to pick A on a select float node. A is 360. B is negative 180. And we're going to take the return value on our select float, and we're going to add it to our remainder. With our wrap angle, okay, resume it, I'm not going to. With our wrap angle function complete, I'm going to go back to our, actually no, we can't go back to our event graph yet. We need to go ahead and do our GetAngleDelta function. On this one, we need 2 inputs and 1 output. Our first input will be start angle, and our second input will be end angle. Our output will be delta. Now, the first thing we're going to do is we're going to subtract the end angle from the start angle. So we're just going to give ourselves a subtract float node, and we're going to cross our inputs and plug them into it. And if this is greater than 180, we're going to get another select float node. Where A is negative 360 and B is 0. And we are going to add the return value to the result of our subtraction. I'm giving myself a reroute node just to try to keep things tidy. I'll give myself 2 of them. There. Okay. And now, if the result of this addition is less than negative 180, we're going to pick A with another select float node. You might be wondering, why do I use so many select float nodes? It would probably be easier to follow the logic flow if I used branches or if-then statements. And it's just because it's more efficient. I can use pure functions, and that makes calculations over in the event graph easier because select float is a pure function, and it's a more efficient way to get to the same result that I'd be able to get to if I was plugging this into a branch and then using that to set 2 different variables and then using those variables. It keeps things more concise. Now, the result of our addition of our first select float and our difference between our start angle and end angle, so this first addition node, we're going to drag out that result, and we're going to get another addition node. Another float plus float. Now our return value is we're going to add our return value for our second select float to it. And this is finally going to be our output. Now we can compile this and save it. We can finally go back to our event graph. And now we're going to do the actual, and that was really close to about half of it, because we have to work in our wrap angle and GetAngleDelta functions into our calculation here. And this is the solution I found, and I don't fully understand the math here yet, and I didn't want to delay the video further. So I apologize if I can't explain this as well as you all would like me to. But essentially, the reason I can't tell you exactly how all of this is working, but I can tell you that it is all working to remove the issues with our separate hemispheres, 0 and 360 being the same value, and negative 180 and 180 being the same value. So we are going to delete our addition and our direction nodes, all of them. And so we just have and we're going to delete all of our orientation direction nodes except for the top. So we have this orientation offset forward set node, and that's plugged into our orientation direction forward set node. Now we're going to get our orientation offset forward, and I'm just going to grab a separate node to keep things cleaner, and we're going to multiply it by -1. And I'm going to get the direction. And I'm going to wrap the direction angle. So I just want to see. Okay, so we're going to wrap the angle with the function that we created. And we're going to get the angle delta of our orientation offset forward multiplied by -1 and our wrapped direction angle. And now we're going to test if this is less than our max warp angle, a new float that we're creating. This essentially just says how far an individual orientation, this determines how far an individual orientation warping node can warp the pose in degrees. So according to our little diagram we did in the last video, each one is set to 90. And so I know that works. I might try a 60 later in this video, but for now I'm just going to get this value, get this variable. I'm going to plug it into the less than node, and I'm going to compile so I can set the default value to 90. And now I'm going to do a little bit of tidying here. And I'm going to duplicate this thrice. Once for each of our directions. And I am not duplicating our set direction node because there's still more to do first. I'm going to drag out from our less than, and I'm going to get a branch. And I'm going to take our orientation offset forward, I'm going to plug it into that branch, I'm going to move our set orientation direction forward out of the way. And so if our angle delta between the inverse of our forward orientation offset and our wrapped direction is less than our max warp angle, we are going to set orientation direction forward to the wrapped product of direction and orientation offset forward. So we're going to add the two together. And we're going to wrap the angle. And now we can take this with our branch node and duplicate it thrice. And now we need to be careful here because we have once we plug everything in, we have some variables that we need to change. Because all of this is setting our forward variable, and it's using our forward offset, which is an issue because we want to do this for each direction. So we're going to replace our orientation offset nodes with the correct direction. But make sure you're using the offset nodes. You're replacing the like the forward with the right offset, the forward offset with the right offset, so on and so forth. Because at first here I was dragging out the wrong node, so I don't want that to confuse you guys. That's all we're changing in our first section. Before the branch, on our second section, we want to change our orientation offset nodes again. Right, backwards, and left. And now I want to change our orientation direction nodes. So we have orientation direction left, backward, and right. Now let's compile, save, and play. And look at that. Our orientation warping is working. So now there's one last thing I want to try, and that's just to change the default, where is it? Max warp angle to 60. I don't think it makes really much of any difference. So there we have it. While starting and stopping and running around, our character can use orientation warping. Our character can use distance matching to start and stop. Now we just need to implement stride warping and turning in place. And the next video will be turning in place, so y'all can look forward to that. I'm not going to be doing any sort of advanced distance matching stuff there. I'm just going to be using I'm just going to be using a normal turn in place method. I'll probably make use of some of the advanced locomotion system animations there too. Hey everyone, I hope you enjoyed the video. If you did, be sure to like and subscribe and hit the notification bell and share the video with others you think it'll help. And again, thanks for watching. I'll see you in the next video, but before I end this one, I know that my explanation of all the math things we did in Blueprints wasn't completely satisfactory. I'm not happy with it, and it's because I haven't had the time to go through, plug in numbers, and really try to figure out exactly how the solution that I found works. And it bothers me just as much as I'm sure it's bothering you guys, because I don't like, just being told to make this node, make that node, and plug them all in together. And so as soon as I have time, I'm going to make an extra smaller video, probably closer to about 5 minutes in length, just breaking down the math and why it works and the logic behind that solution there. And so I'll see you all in the next video, which might not be that video. It might be a little while until I have the time to sit down and go through that, depending on how things go. I'll try to make the time, but anyway, thank you all for watching, and I'll see you in the next video.